Chapter 16, Just-in-Time and Lean Operations. This session will help you understand lean operations, the 7 wastes, and the 5 S's, along with the importance of supplier partnerships. You can't have top quality products without top quality components from top quality suppliers. You will also understand setup times, just-in-time operations, Kanbans, and the attributes of lean organizations. Toyota has been the breeding ground for quality and process innovation for years. They are one of the largest auto manufacturers in the world. One key to their success has been the implementation of just-in-time and total production system. For just-in-time to work, the team must work constantly to improve the process and eliminate the issues that prevent the smooth flow of material. The result is the creation of vehicles with high quality and lower cost due to minimal assembly time. Here are the elements of the TPS system. You find optimization in all aspects of production. Hiring the best people and treating them well is foundational. The factory is level loaded with materials delivered just in time using a pull system. Standard work practices are used for consistent quality while using custom machinery to produce the best results. Processes include the use of display boards, monitoring performance, and continuous improvement. This is not a single approach, but a coordinated effort applying best-in-class techniques. Lean operations are all about reducing waste. The customer gets just what they ordered with no excess cost, material, or labor. This strategy is supported by just-in-time and pull methodologies. The difference between just-in-time and lean is that JIT is time-focused while lean is focused on eliminating waste. The combined goal is to eliminate waste, remove variability, and improve throughput. How do we define waste? Waste is anything that does not add value from a customer point of view. In other words, would the customer choose to pay for it if offered as a separate option? In our previous discussion of value-added processes, we identified that storage, inspection, delay, queues, defective products, and unnecessary travel are all considered waste. Taiichi Ohno, father of the Toyota production system, identified 7 types of waste. They are shown here. This list is a great starting point when identifying waste in an operation. Overprocessing is adding more value to a product than the customer requires. This waste is controversial as it suggests that it is wasteful to give a customer more than they paid for. Waste includes unnecessary use of energy, water, and air. An optimized process minimizes required resources and reduces waste. The process of facility housekeeping has been expanded to the 5 S's. The 5 S's represent a Japanese methodology for workplace organization. Each S represents a step toward optimized workflow. Sort suggests eliminating items not needed for the work. Straighten means to organize the materials and tools to improve efficiency. Shine means to keep the area clean, while standardizing steps might include color coding to ensure consistency. Finally, any improvements must be maintained over time. This is the meaning of sustain. 2 additional S's have been added to the original model. They represent safety and support/maintenance. Stable processes are important for customer quality, productivity, and minimal cost. Eliminating variability helps you achieve this goal. Inventory is often used to hide variability. Excess inventory builds a buffer between processes that are not in alignment or have excess variability. Poor processes and inadequate maintenance of those processes can create preventable variability. The same may be said for inconsistent customer requirements and incomplete product specifications. Just-in-time methods and inventory reduction efforts can help identify and reduce sources of variability. To measure the success of a process, we look at several key metrics. Throughput is the rate at which units move through production, while cycle time is the time from arrival of raw material to the shipment of the final product. Order cycle time starts with order receipt to customer delivery. This would be the customer view of the process. Improvements in throughput may result from reducing lot sizes and by using a pull system where inventory buffers are removed and exposed problems are addressed. As a result, manufacturing cycle time will be reduced. Push systems are the traditional method of pushing material downstream regardless of need. This is not an effective approach. Combining lean and just-in-time is a powerful strategy, but requires a strong relationship with suppliers. The result can be reducing waste and increasing throughput. Implementing a just-in-time methodology can create a competitive advantage. This list displays many of the potential outcomes. Key results include improved quality, reduced cycle time, stronger supply chain relationships, more accurate schedules, and a flexible, empowered workforce. Typically, we think that improved quality and reduced cycle time increase cost. However, the ultimate result of just-in-time methods is a faster response to the customer at lower cost and higher quality. To make just-in-time methods possible, strong supplier relationships are required. The goal is to create a partnership where both companies work together to streamline processes, reduce inventory, improve quality, and reduce response time. As in any partnership, both parties, the buyers and the suppliers, share the tasks necessary for success. Risk is involved on both sides, such that mutual understanding and trust are required. Both parties are sharing information that would traditionally be considered a trade secret or for internal use only. The risks to suppliers are numerous. One of the greatest long-term concerns is diversification. Partnerships often evolve to a point where items are single-sourced. Business issues with the buyer can have a major impact on suppliers. It is not uncommon for a bankrupt buyer to take suppliers with them into economic ruin. In addition, the two companies must be in alignment regarding quality, lead times, and expenses. Facility design can also be affected by a lean methodology. Here are a few of the tactics that may be implemented. Poka-yoke devices are tools or fixtures designed to work one way only. Assembly errors can then be reduced or eliminated. A simple example in everyday life would be a three-pronged electrical plug. It can only be inserted into the outlet one way. Another step is to reduce distance traveled during the process. Flexible work cells and realigned equipment aid in this goal. Flexible work cells contribute to the agility of a company. These concepts apply to both production and office environments. This flexibility can be used to adapt to changing demand and changing product requirements. A flexible workforce can make a big difference in an operation. Employees trained for multiple jobs facilitate flexibility as business needs change. Tools and methods like Poka-yoke also help. With an optimized process, material velocity increases. The result is less inventory storage. This is the definition of lean inventory. To establish and maintain a lean inventory model, a number of methods are used. Some examples are listed here. The following content describes many of these methods. Inventory is often used to hide problems in the process. Variability in process performance is often the problem. If process activities can be predicted consistently, the process design can adapt. However, with variability, the process is in constant turmoil. This diagram depicts variability as rocks in the water that the sailboat must avoid. As long as we have sufficient inventory, the boat sails smoothly, ignorant of the rocks beneath the surface. But as inventory is reduced, shown as a lower water level, the rocks are exposed. Now that the issues have been identified, employee teams can address the identified issues and reduce variability. Once these issues have been resolved, the inventory or water level may be reduced again, identifying additional issues to be addressed. This technique is often used by companies attempting to reduce their inventory levels. Inventory may be lowered temporarily to identify the issues. The inventory may then be increased to ensure business success while the issues are addressed. The levels are then reduced again to determine if the action plans have been successful. Ultimately, when all process variability has been reduced or eliminated, the inventory or water level may be reduced to a level that minimizes carrying costs while ensuring business success. Here is a summary of the process of inventory management. The goal is to minimize inventory by eliminating the exposed problems. The graph depicts inventory quantities over time. The sawtooth is an idealized view where 200 units are ordered and placed into inventory. This is the vertical spike in the line. As material is consumed by the process, we see a gradual drop in inventory until the next shipment arrives. Ideally, the next shipment arrives just as the inventory is depleted. Since we have a triangle, the average inventory is simply half the height of the triangle. Thus, if the order quantity is 200 units, the average inventory is 100 units. A direct method to reduce inventory is to reduce lot sizes. By reducing the order quantity to 100, the average inventory is reduced to 50 units. The average inventory is proportional to the average cost of inventory. Just-in-time methods would have an ideal lot size of 1 unit. Due to a number of realities, this is not always possible. We can calculate the economic order quantity, or EOQ, to balance the various production inputs. As with most equations, we determine the given values and determine the unknown. For example, with an annual demand D of 400,000 units, a desired order quantity Q of 200 units, and an annual holding cost H of $20 per unit, we can determine the setup cost. The equation determines that the setup cost will be $1 per setup event. Since labor costs are $20 per hour, the setup time is determined to be 3 minutes. To reduce lot sizes, reduce setup time, and setup costs, setup can be simplified by pre-planning cutover activities, implementing advanced automated processes, and eliminating setup altogether by using more universal processes. This is a graphical representation of the EOQ equation showing the impact of reduced setup cost on lot size and cost. Reduced setup time results in reduced lot size and reduced cost. This diagram shows the typical steps taken to reduce setup cost. The target in many industries is to achieve sub-minute setup times. This is the Six Sigma of setup goals. Lean scheduling brings all members of the supply chain in alignment and includes frozen schedules of small batches of material with demand based on a pull system based on need. Improved scheduling methods result in improved performance. Lean scheduling tactics are listed here. Some methods are unique to scheduling, while others, like performing to schedule and eliminating waste, can have a broader impact and are just good business practice in general. Level schedules means that there is a fairly constant volume of material flowing through the process based upon a constant demand. Smaller lots and just-in-time procedures are possible with resulting economies and reduced variability. Here we compare a just-in-time approach with large lots. Notice that it takes longer to get the third product C built. This advantage has a cumulative effect if multiple processes are required in series. The Kanban method is a just-in-time method originating at Toyota in Japan. A signal is needed at a later process, places demand upon a previous process. Materials pulled through the process until the final product is delivered to the customer. Here's an example of a Kanban. As the boxes on the right are used in the process, eventually the flag for that product is exposed. This flag is placed on the flagpole to indicate demand to the previous processes responsible for producing the boxes identified as X201, Y302, and Z405. When the material is placed back in stock, the flags are replaced in their respective stacks. Kanban indicators may be visual if the producing group is nearby or electronic if not. Note that the number of boxes in reserve is dependent upon the speed of fulfillment of the providing group, plus the rate of depletion of stock in inventory. Here we see another example showing the flow of material from component suppliers through to fulfillment of the customer order. Each stage loads demand upon the previous group as local inventory of work in process goods is depleted. Some of the advantages of Kanban are listed here. In general, Kanban does not create success. Successful Kanban forces changes to the operation to be successful. These changes improve business performance. There is a strong relationship between lean operations and quality. Lean operations expose issues including quality. Similarly, good quality is required for lean processes to be successful. Tactics to achieve lean quality are listed here. These are not new concepts, but the focus on lean quality brings them to the forefront. To be successful, lean operations act differently. There must be a strong relationship across the supply chain, starting with material suppliers, through the distribution channel to the ultimate customer. Communication and the consistent use of lean methods across the supply chain are essential. Becoming a lean organization is not easy. Cultural change is required along with open communication at all levels of the team. Gemba is from Taiichi Ohno and translates to the real place. In management terms, a Gemba walk means going out and viewing the actual operation and understanding the reality of the situation. This further supports the open communication listed above. In addition to open communication, employees must be empowered for success. Workers with multiple skills are desired, and the focus must be on value-added tasks. Once achieved, maintaining lean operations requires looking beyond the team to those external operations that interact with the team. Working external to the firm is the next opportunity to enhance the process across the supply chain. The techniques of lean apply equally to manufacturing and services. Can you think of examples where this is the case for a typical service?